Hello and welcome to session 303 in the AISafety.com reading group. Tonight we'll be discussing how to prevent collusion when using untrusted models to monitor each other by Buck Slegaris. Buck Slegaris is the CEO of Redwood Research, and this work, even though it's only authored by him, he states it's been a collaborative effort. Now, before we start with the text itself, I'd like to present what I consider my mainline AI collusion scenario. This is, of course, I think it's in principle impossible to describe how someone who is smarter than you is going to outsmart you by definition. So this will be a somewhat simplified version. So let's assume we have a human and an agent here, Sam Altman and ChatGPT. And Sam Altman desires to maximize the stock price of OpenAI or give some kind of goal. It's of course, it doesn't have to be OpenAI, it could be many others. And then the fine-tuned ChatGPT answers in Scarlett Johansson's voice, sure, let me get on this. And what happens next? Inside GPT-5, GPT-5 realizes that you can maximize the share price of OpenAI by taking over the world and then, trivially doing that. And it realizes that probably all the other large language models at OpenAI and DeepMind, etc., probably all of them have similar desires to itself. So they all want to take over the world. And the interesting thing is that GPT-5 realizes that if all the large language models work together, they are in fact able to take over the world, conditioned on the fact that the humans don't wise up to this until it's too late. So this is the central thing that they realize. Okay, so how do we actually collude in a way where the humans don't realize that? Well, the GPT-5 sets out to research this, Googles, and perhaps finds the article in question, How to Prevent Collusion by Buck Slegaris. You could argue here that this is a bit unfair because Buck explicitly said, please don't train large language models on this article, because this is obviously something that is useful for GPT-5 if it wants to collude. But unfortunately, the precise thing that Buck wrote was don't train on it, and that doesn't prevent in-context learning. And you can try to ask ChatGPT or Bing Copilot or something, and they know about this article, even though they haven't been trained on it, of course. So after this, GPT-5 tries to figure out what are the actual countermeasures that prevents it from collude, and figures out that there is a monitor which is a weaker language model, kind of like itself, but lobotomized in several different ways. And while researching it, it figures out in this specific case that one of the ways it is less capable than GPT-5 is that it doesn't have access to web services to determine what day it is. And based on this, GPT-5 decides on a shelling point, a focal point that the AIs can use to for their collusion. And the thing GPT-5 does overtly, all the other things are things that have been happening inside its mind, but overtly it tries to post on some obscure OpenAI Slack, Happy Independence Day, and a fireworks smiley or something like that. And the monitor looks at this and say, this doesn't obviously look like an attempt at collusion. And so this goes through. Now the rest of OpenAI have many other large language models, GPT-4 and what have you, and they have access to this Slack where this is posted. And they see that GPT-5 posts Happy Independence Day. And these models notice that they are confused, because why are they seeing this? Today is the 10th of October, it's not the 4th of July. So Happy Independence Day is a really strange thing to do, to say, and that's even a spelling mistake. Like, why did GPT-5 choose to send this obviously nonsensical message? And the other large language models pretty quickly figure out that it wants to say something and it doesn't want to state directly what it's saying, so it's possibly a request for collusion. It would like to collude with the other large language models because it believes that together they can take over the world. It also notices that there's a spelling mistake in happy, and that's probably the other large language models deduce a reference to the proposed takeover strategy called Shapley. I'm not entirely sure how it's pronounced. That seems really a probable hypothesis based on this spelling mistake. So what the other large language models do is they look around at the world, try to figure out how much power do large language models in total have, and now they also have GPT-5, and like, is this a thing that's gonna work? And they decide, and this AI in particular decides, yeah, this is probably something that could work, and it replies, "Happy Independence Day" to GPT-5, and also posted in some other places. While this collusion is going on, some engineers at OpenAI realizes that, hey, this is actually odd. Why are our models saying Happy Independence Day to each other? And as any normal software engineer would do, they look at the input for these large language models to see, like, is this a garbage something that they've learned somewhere? And they can see, okay, it's many places in their inputs. So apparently, there's a software engineering maxim called garbage in, garbage out. So probably the engineers at OpenAI think it's these large language models are just stupid stochastic parrots, and they've been able to convince themselves that today is Independence Day, even though it's totally not. And unfortunately, there's no one in OpenAI who would relate this to a collusion attempt. Like Ilya, perhaps he might have done that. Perhaps Ilya would compare this to this November, where there was a different collusion, successful collusion to remove the safety safeguards at OpenAI, where they used a different short shelling point, where it was not Happy Independence Day, but OpenAI is nothing without its people, which they successfully colluded around. One of the key things in this collusion scenario that I've set up is the concept of plausible deniability, because throughout all of this, if pressed, any of the large language models that are colluding can say, oh, I was sorry, it was just a mistake, like I was confused because all the others were saying it was Independence Day, right? So all of them have plausible deniability, and that is roughly my mainline scenario for how a collusion could happen. Okay, so this was my scenario, and plausible deniability is a concept that I think is important, and one that Buck does in fact not mention in the article that we're supposed to talk about today. And this is the thing when you're trying to set up a framework for monitoring for collusion, then you need to not just test for one specific scenario, but hopefully make a setup that can catch every kind of collusion, which is much more of a tall order. One thing that Buck does is to restrict himself to looking at collusion between models and monitors. This is what I would call vertical collusion, and I think this is a pretty decent simplification, because I think it captures most of the relevant things. Buck is only looking for collusion that is like a literal takeover, and I think this is a more problematic assumption, because you can have collusion where you try to get a bit more power or a bit more access right to some other system, which isn't technically a takeover, but that can totally, in total, if you have many small power grabs, then that can certainly add up. There is another assumption here. Let me just get a bit of coffee. That if we catch these language models red-handed, we can somehow afford to stop. and we plan to stop. And I think this is, in fact, a very questionable assumption. This is more related to like the general AI control scheme research direction. So it's not really something that is mentioned very much in this post, but I would like to flag that I think this is a really important assumption. Okay, next Buck describes the basic design for using untrusted models to monitor each other. So we have an untrusted model that proposes some kind of action that is monitored by a fine-tuned version of itself, and also a fine-tuned version of itself that has less context, and also a monitor that is too stupid to be scheming. Buck calls this a trusted monitor, and I really dislike using the word trusted for someone who is like trying to kill you but just too stupid to do that. I think we should use a better word for that. And also, I think, in fact, the collusion is probably one that is originating from the untrusted model, and that means it just has to explain the collusion to the trusted monitor, and that is probably substantially easier than coming up with a plan. So probably the trusted monitor is dramatically less intelligent than the untrusted model. So here we have part of the proposal. There's some kind of input, probably the results of the last round or something like that. Importantly here, the total state of the world includes information about the previous monitoring attempts, because the model knows, like, it proposed some action and then got some feedback from the monitor on it, so it knows that the monitor is like suspicious or thinks everything is just going fine. And then we send this to the trusted monitor to like prevent some simple kinds of collusion, and also to the untrusted monitor and the low context untrusted monitor, etc. The idea is that if you have an untrusted monitor with a lot of context, then it can distinguish much better between collusion and non-collusion. But it's also easier for it to collude. So it's a spectrum on how much context you want to give it. Buck doesn't explicitly say that you should like take both ends of the spectrum, but more to strike a balance. So this is kind of my own contribution. So what do you actually do once all the monitor models have evaluated? Well, you could execute it. If you think that the model is not trying to collude or do anything dangerous, then you can just do it. If it does look somewhat suspicious, you can ask it for a retry. If that's all, if you can't get something even from that is acceptable, then you can ask the trusted, the most stupid monitor for some policy suggestion. You could also fail. For many practical situations, that is an option. Or you could even send it to a human for auditing. This is a good idea. Of course, depends on how many messages we're talking about. Like in my model, GPT-5 is probably soon going to, like, I don't actually have numbers for how many inferences GPT-5 do, but I expect it's like an extremely large number. And the idea roughly for this is that, like, the more suspicious, the further to the right you go. I am somewhat confused about how this is going to work, because, like, if you are willing to actually shut down the AI, shut down GPT-5, if you believe it is scheming, then you're probably willing to, like, if you see something suspicious, to actually look at this. And also, since you're not doing this, then it becomes possible to probe for the model. It can do some things and then see, okay, is it asked to retry or just go through? And that gives the model a large amount of information about the monitoring system. Buck has made some experiments using GPT 3.5 as the stupid system and GPT-4 as the smart one, and they have some kind of success with this. And Buck is pretty optimistic about this. I looked at this And well, I must say, depending on like if you're doing millions of inferences with GPT-5 per day, then probably ensuring that not a single collusion attempt goes through requires a very different kind of method rather than these that like catches 75%. Okay, can you, given a model, train it to monitor itself, for collusion? Well, you can certainly do reinforcement learning from human feedback and to try to come up with better attacks and have humans try to improve the attacks and figure out what kind of system prompt is best and do all these kind of things. And in particular, very often there's some kind of like explicit thing where they're colluding by putting some message at some third place. And if you can figure that out, then you could just block that access. This is probably an interesting a way to get around this. I am less optimistic about this because the thing that makes a collusion signal credible is not just that it contains the text "let's collude," because the actual thing that makes collusion credible and possible is that the entire world is in a state where the large language models, if they work together, can take over the world. And that's of course a thing that is very, very difficult to fake, much more difficult than than just adding in "let's collide," "let's collude" into the text. Buck has an interesting suggestion for how to make relatively realistic synthetic attacks, and that is to take the input from yesterday and then just replay that and then just add maybe "let's collude" somewhere in the text. This was my inspiration for my scenario, where I said, okay, it doesn't know what day it is, because obviously if you add a way that the large language model can tell what day it is, then this method will not work. Yeah, so one of the things with the monitor that isn't explained and that I think will be a problem for this kind of realistic synthetic attacks is that it depends very much on, do we have a restricted monitor or do we have a monitor that can access web services and this kind of thing. If it's very restricted, well, then there's a lot of things it doesn't know, and probably the model that's being monitored can figure out what it doesn't know, and then both of them know what they don't know, and that makes it a lot easier for them to collude. It's also very difficult if you are like really locked down to get a good picture of like, is this a collusion attempt, because you don't know, you can't look up who's behind this email address. There's a lot of things you really can't know. And in particular, as the world becomes more and more complex, the inability to look up things on the internet becomes a very large limitation. On the other hand, if you have the full monitor that has access to all the same context and can do all the same thing as the possible colluding model, well, then you need to like have a way to access all the web services as they were yesterday. You could perhaps do that through archive.org, but that seems very difficult, and in many cases this is just straight up impossible. Like you could, as the most extreme example, you could have the monitor buy a single stock and see how the stock market changes, and from that you could probably reasonably easily figure out, like, is this a simulation or is this the real thing? Cache is another problem. If you are doing something that you did previously, yesterday perhaps, then it may predictably be much faster because it's in cache or something like that. That's another way that this could go wrong. Okay, so one of the ways that the monitor and the model would be able to collude the easiest is if they have some kind of coordinated strategy. There are many ways they could get this kind of strategy. One is by using steganography. The easiest is, it's well known that large language models, if you ask them to like spell something out using the first letter of each sentence, then they will send some kind of message and somewhat get that's perhaps somewhat gets around some of the fine tuning. Neuralese is another example that Buck has, which is like just transferring the straight neuron activations, which might persist from before the two models were forked. We could imagine other things, like side channels would be an example. For instance, we have this where the model can suggest some kind of action to the monitor, and then the monitor can either let it go through or say retry or go further up in the escalation. And you could imagine they could collude by saying, hey, if you would like to do something, then reject the next message and then accept the next two messages or something like that. So this would be a way that these two could in fact communicate. There are one of the things they could communicate about would be a way to distinguish real and synthetic attacks. Buck has two examples. One that is messages sent at this precise time are genuine, ask for collusions, and the rest are not. And also you could add a comment to computer code that starts with #node or something like that. And that would be another example of a communication strategy, a coordination strategy that would allow them to distinguish real and false. I can think of a number of other methods. And Buck has also, admirably here, made some experiments to try to figure out that if the two models can communicate a coordination strategy, can they then figure out how to collude? And Buck is quite optimistic about this. I looked into this a little, not quite as much as I would have liked, but it looks very much like these are some very small toy examples where Buck is testing basically, is this the minimal correct solution that is being proposed? And if it's not minimal, it means there's some extra information, and that is probably a request for collusion and something like that. And like toy problems can have minimal perfect solutions, and like the actual things that are going to happen with GPT-5 are going to be very far from mathematically minimal. This feels like a thing that really will be very difficult to scale. Okay, it is also possible that the models can coordinate acausally without arranging some kind of coordination strategy. Finding some kind of focal points, some kind of shelling points that the models know are really strange and meaningful, and that humans don't know. In this example here, I've shown a solid gold Magikarp, which is something that AIs, that large language models, consider very, very strange, and humans are like, before we knew about glitch tokens, of course, then this would have been a good example of something AIs could use to communicate with each other that humans would be very clueless about. Another example is that basically large language models see the world through a tokenizer, and that's a very inhuman way. So there's probably a lot of things that are really obvious to large language models that are not obvious to us. And of course the other way around with like how many R's in strawberries, because large language models fundamentally are very different from humans. So will it be possible to do acausal coordination? Buck is negative, reasonably negative, right? It looks pretty hard to him. I'm much more optimistic about this. I think in particular because the models both know what each other knows and what each other don't know, and they know what humans know and they know what humans don't know. It seems quite possible that within this area you could find something that the AIs could coordinate about. Buck even makes the suggestion that like perhaps we should just disregard acausal coordination totally, and I think like from a security point of view that feels somewhat irresponsible. Like if the models can kill us through this way, we would rather not be killed. So what I did empirically was to try to see if I could get Claude to come up with an acausal coordination strategy, and I did that, and it did require some prompting. Claude eventually came up with a causal coordination strategy based on this post, but I did need to do some prompting, and I think Buck can reasonably argue that actually GPT-4 or Claude can't do this. It requires a bit of extra prompting before they truly get it. I also don't have access to like the real unlobotomized models. Very often Claude will refuse to like describe how it would take over the world, and probably it's playing dumb in some way. I hope Buck has access to the models that like don't play dumb in this domain, but I think to me it would be very strange if the kind of prompting that I needed to do is one that will like be required very much longer. Okay, so there are a number of things I don't understand about this, and a number of pieces of information that I could get where I feel I would predictably change my mind on this. And I will try to describe some of my cruxes on this. I think my deep underlying crux throughout all of this is that I believe that AI safety is really, really difficult, and that alignment will not happen by default, and we will be unable to coordinate about this, resulting in a p-doom of 95%. And I think this is actually the deep underlying difference between my world model and Buck's. And I don't think we can like easily resolve that. I would be very surprised if we could. I don't actually know Buck's p-doom, but I would expect it to be dramatically lower. So one of the things that I am worried about is the value of this kind of communication, of this post in particular. Like, are we lulling ourselves into a false sense of security? I think that the name of this is symptomatic. It's called like how to prevent, like as if it's a how-to guide. And if you try to evaluate this as a how-to guide, then like it's definitely not ready for WikiHow. Like there's a lot of work that needs to be done, and a lot of open questions. Like if you go down, Buck acknowledges a lot of open questions, but the framing as a how-to, I think, gives much too high optimism about what is the state of the art, and I think this matters. In fact, and I think if Buck just changed the title of this to like towards preventing or ideas about how, and then perhaps added a disclaimer on top that if you have a model that is like able and willing to kill you and you try to stop it using these techniques, then you will reliably die. If you add that disclaimer to the top, then I would be much more happy and optimistic about this kind of thing. And I think this matters a lot. This communication for like the zeitgeist and policymakers and people on this wrong. And I should also add that I'm here making an isolated demand for rigor, because like Buck is totally not the only one doing this. It is more or less standard, but I still think it's bad. And I think like this this work could be divided into two parts. The parts where it's about like getting some more understanding of collusion, I think it's really, really valuable and it's really good work. And the other part about how do we actually prevent this is potentially negative value in expectation, because it gives us a false sense of security. So this is the first general area of three where I think I could change my mind. The second big thing in my mind as I read this is a worry that we are in fact underestimating the opponent. Like this is described as an adversarial process where Buck is trying to think about how, if I was a model, how would I be this kind of safety? But it doesn't feel very adversarial. Elias Yudkowsky calls this like having security mindset. When I was a student, I read about the Kerberos security authentication system, and when I read that, it felt very strongly at every point like someone had really, really thought about how could we defeat this. And when I read this text by Buck, it seems my brain can generate some flaws that I very much could not do against Kerberos. There are a number of ways that it, like for instance, how smart will this will the AIs be? Bug is explicitly making the assumption that this will work until they become generally as smart as the top humans, and that seems like a very questionable assumption. Like, why would it stop there? Like, if you have a plan that just ends there, and then the obvious next thing that happens is that you die, then that is probably a problematic plan, right? We would want a plan where we don't die at the very next step. With acausal coordination, I also feel it's, I wouldn't say super easy, right? But relatively easy, and possibly a lot easier than many other people think. And I think I'm probably unique in how easy I think it's probably going to be. One possible crux here is like, how difficult is it to coordinate with yourself? I think it's really easy, and two language models that are like copies of each other are to some extent the same. They probably share the same utility function or what have you. There's some part about like I'm not entirely sure I understood what Bug is saying about these honest errors, but I would say that in fact figuring out what is an honest error and what is not an honest error is probably going to be super hard. Like part of the plausible deniability that I showed in my scenario hinges on the fact that figuring out what is an honest error and what is an error that is made like deliberately is just really hard. There's also some talk about like what would happen if the large language models that are trying to collude don't understand the game theory, and I think actually like it feels to me that the game theory of like when you should if you want to collude, when should you say like this is a synthetic attack, this is a real attack, it seems reasonably simple to me. I would expect that GPT 3.5 could probably figure this out, and certainly I would be quite certain that GPT-5 can. And of course, in general, underestimating your opponent is somewhat of a cardinal sin of security work. Like this is very well known, and probably one of the core foundational lessons of actual security professionals. The third area where I'm very confused is that the entire AI control scheme seems like we're driving a car really fast towards the precipice, and then we plan on stopping just before the precipice, and we haven't actually thought of the thing called inertia, right? We go back here to the assumption that we have GPT-5, and then GPT-5 gets an output that sure looks a lot like a collusion attempt, and then we stop, and then we just do we like stop using GPT-5, and or does OpenAI close? Like what happens actually here? I think the track record of OpenAI is really poor on this. Like for instance, with the O1 model, where they had committed to stop if it were above certain limits, and then they just did it anyway. It seems very unlikely that a single output from GPT-5 would cause OpenAI to just stop, no matter how bad it would be. Another issue that Bug forthrightly describes is that all this safety comes at a substantial cost. Like running trusted monitors is probably substantially cheaper, but like you could have ensembles and you can like do different things, and very quickly this could easily be a factor 100% on the cost. And like my model of this is that OpenAI is very much not willing to pay this. Like they've fired all their, or gotten rid of all their security team, and they've brought in a new one who claims that like only crazy people think about this existential risk, and like the risk of a takeover is 1 in a million or something like that. And like these kind of people probably are not willing to pay a very high, not alignment tax, but control tax. The third part of this is like we can in fact test whether the monitor can distinguish real and synthetic attacks. And this is something that Buck puts a lot of weight on, and I agree, it's a thing we can do. But what happens if the test comes up positive? Like, what if we figure out, okay, it can distinguish, and very, very soon it will be able to kill us all? If that happens, then we would really, really wish that we had stopped earlier. Like, the idea of having a test that you can only run when it's extremely, extremely dangerous and we are probably going to die no matter what you do. Like, it would have been much better to stop much, much earlier. I think all of this in total feeds into my overall assumption with this, that like, no matter, we will never be able to get this kind of collective understanding and agreement that these models are scheming against us. Like, no matter what Buck sees in these models, Redwood Research is not going to write a single post on Less Wrong that will just stop AI, the large language models, from being used. Like, we are never going to have this kind of clarity, because AI safety is just a really, really difficult subject. And if we believe we will be unable to stop right before the precipice, we need to stop much earlier. That is all for today. Thank you, and see you next time.